Hello guys! This video topic is about the Access Control List, ACL. As we know, now we already have lots of technologies, right? We can use some layer 2 technology to follow the traffic in the same segment. And we also have layer 3 technology to follow the message between different segments. So, basically, we can make the traffic to any source to any destination. Now maybe we will have a new requirement. We want to control some traffic. For example, the traffic from the IT to finance, the action is denied, but we can allow the message from the other department. So in this scenario, we will use a new technology, we call it ACL. We can make lots of rules and to select the rule we want to control and then to give different actions. And how to do the configuration, what's the detailed principle. If you are interested, please follow me together and we can discuss it. Thank you.
Hello guys, this video we will talk something about the ACL, Access Control List. And before we talk about the detail, let's have a review some practice question of OSPF. The first one, the OSPF administrative distance on the RGOS platform is, the answer is option A, right? It's very easy for us. And the number of 89, this is a protocol number. When we encapsulate the OSPF message into the IP layer, we need the protocol number to distinguish different IP layer protocol. And the second question, what is the default OSPF overhead for an interface with a physical link bandwidth of 5 Mbps? The answer is B. Do you still remember the form? The cost value will be calculated by the format 100 Mbps and divide the physical bandwidth. And 100 divided 50, the result is 2. So if your bandwidth is 50 Mbps, finally you will get the cost value to become 2. And the third question, which of the following statements is false? And the answer is option B, C, D. So about the option A, this description is correct. OSPF's hello message carries the default device priority is 1. This priority will be selected to become DR or BDR or maybe DR other. Option B, any router in the OSPF area can perform route summarization. And this one is wrong. Only the special router like the ABR and ASBR we can do the function. You only remember this one in the course is enough because we don't explain how to do the summarize, right? Not every router can do this function. Option C, OSPF gives preference to the IP with largest physical IP address as router ID. So this one is wrong because about the principle how to select router ID. If we have the logical interface, loopback interface, we want to choose a higher, the largest IP address of a loopback interface. If we don't have the loopback interface, then we need the select the physical IP address to choose the largest IP address, but we need the active interface, right? So the option C is wrong. And the option D, route ID of 2 routers in the same OSPF area can be same. No, the router ID must be unique in the same area. This is the name. Different router, we need the different name. So the option is A, B, C, and D. Now let's see the detail about the IP access control. Actually, why we need the IP access control? And this technology can be used for the packet filtering based on the policy we define on the devices. If we use this technology, we can allow the packets on an interface to be controlled and allowed to pass or maybe directly discard based on our requirement. And this ACL can be used on the router and also the layer 3 switch. Of course, someone say on some firewall devices, you also can use this technology. With the help of access control list, user access to the network can be effectively controlled, make our network more security. So this is the basic function. And now let's say the application scenario. Like this topology, we have several terminals and they connect with the access switch and connect with the distribute switch, finally connect with one core switch. And this is a typical network structure in the real network. And in this scenario, maybe we use lots of technology, right? Like the VLAN to make the broadcast domain smaller, and maybe give the IP address and give the layer 3 routing information like the static way, maybe some dynamic way, something like this. And then after we use this technology, and all the terminals can wait with each other because we already give the routing information on the core switch or maybe the distribute switch. Then maybe we have the other requirement, right? For example, when we want to control the traffic, the PCA can communicate with PCC. And if we add the technology of the VLAN and the routing and some of the other technologies, this one is a basic requirement. But we hope that PCA cannot communicate with PCB, cannot do the communication. So this is our requirement. Someone say you can directly to control the routing information. For example, the PCB route done to distribute by the core switch. So if the core switch receives a message from PCA, we cannot wait to the destination to PCB. But in this scenario, if you direct to discard the routing information, that means PCB cannot do the work, cannot do the communication with all the segment because we don't have the routing information. But our basic requirement is only PCE and PCB cannot communicate with each other. If the PCB and PCC, they still can do the communication. So in this scenario, the basic configuration, you have to make all the networks, the routing information successfully, then you can add some ACL to do the control. So you have to know the relationship. The routing information is a basic requirement, and this one can make all the segment traffic to do the communication with each other. Then you can deploy the ACL to control some traffic. So this is a basic one. And also the other application scenario, like the network in the company, and some employees we think maybe belong to some special department and they cannot wait with the special segment, something like this. Like the topology, the employee 1 and employee 2 cannot wait the supervise A and the supervise B. So this also is a very typical requirement. Like some guests to wait our network, they only can wait the internet but cannot wait our internal resources. Some requirement like this. So in this scenario, on some special devices, we have to deploy the ACL. And the basic function, ACL full name is Access Control List, and we can define a series of different rules according to the configuration. And pay attention, the ACL, you only can define the rules. For example, I want PCA can forward the message to PCB, and PCA cannot forward the message to PCC. Some rules you can define like this one. But if you want to let the ACL working, you have to apply the ACL in the places, in some special places. The typical application is on the inbound and outbound interface, you can use the ACL. And then once the interface receive or maybe send out the message, if you apply the ACL on this interface, then the interface will do the check. I will directly send out or maybe match the ACL one by one, and according to the action, finally maybe I will still forward the message out or maybe discard the message. So pay attention. If you don't add the ACL on your interface, maybe the router takes the message according to the destination IP address, match your IP routing table. Finally, I can directly forward the message out. But if you add the ACL, you want to do some control. So in this step, maybe you need more time to check the policy, and you need the resources. So this one will make your time limit bigger. So pay attention about this one. And about the ACL, we have two main functions. One we can control the traffic, right? Control the traffic. And another one we can control the routes. So this one belongs to different type. The metric means you can think this belongs to the forwarding plan. We already deployed the network connection successfully, and then all the devices can forward the message successful. And now we want to control the traffic. The typical one likes the NAT and the QoS. NAT we will explain on the next video, network address translation. And in these two scenarios, you can use the ACL to select some special metric, a special packet, and then to do some actions. So this action belongs to the traffic. And another one, you also can use the ACL to control the routes. For example, when you get some routing information from your neighbor, you can use the ACL to control, to add some routing policy. For example, if this route match our rules, finally I will discuss the route information. Of course, if you don't have the routing information, you cannot forward any message to this destination. So this is the first one on the routing policy. And another one is the routing redistribution. Redistribution, you maybe can think, I already get the segment A from the OSPF. And I also have the segment B from the static way. And I need to tell the segment B this segment information to my neighbor. So I have to make the static way to become OSPF. Then I can directly send the routing information to my neighbor. So this process we call is redistribution. And in this process, we also can use ACL to control. For example, about the static, you have 20 segments, but I only want to let my neighbor know 5 segments, so you can use ACL to control. And about the matching routes belong to the control plan. If you filter this route information, finally all the segment packets cannot be forwarded successfully. And about the NAT, or maybe in the future, we talk about the QoS. We only control the traffic, but all the devices learning the routing information successfully. So this is two types of traffic we can control. And how to define the special rules? We have to use ACE, access control entry. And one ACE is one rule in the list. Of course, you can make multiple rules in the list. And the order of ACE matching from top to bottom. That's why we say you can add more multiple rules in the list, and each rule we will have the sequence number. And when we receive the message, we will take the message to match from top to bottom. If the number is matched from lowest to highest, because each entry we will have the sequence number, right? And we will match the lowest number to highest number. Once matched successfully by an ACE, whether the action is deny and permit, because about each entry we will give the action. For example, this message can match the rule. Finally, we will allow to pass or maybe directly to discard, something like this. If we match one entry, we will stop match the rest entries. So this is the principle. After all ACE, there exists a default ACE, deny IP any, and if you want to use a command to show your configuration of ACE, you cannot see this command. You cannot see this ACE. So pay attention, please. If in your ACL, you define maybe multiple entries and all the entries is denied, that means you will discard everything, because although maybe some metric cannot match the entries you configure on the devices, right? And finally, we will match the last entry and everything will be denied. So in the real network, maybe we will have one ACL to allow IP any, to permit IP any. So pay attention about this one. In the action of ACL, we have two types. One is permit and another one is deny. The permit means we will allow or match the date or maybe the root of the statement after the permit. And the deny means we will do not match the date and the routing information of the state after the deny. So we only have two actions of the ACL, and when you define the entry of the ACL, you must select one action, permit or maybe deny. For example, here is a command, IP access list and the standard one, and you have two entries, 10 permit IP 192.168.1.0.000.255, and the next one is 20 deny IP, something like this. And what's the function of each parameters, we will explain one by one. But pay attention about this part. You at least select one action on the entry, permit or maybe deny. So this is the basic action, permit and deny. And then let's see the process if we already make the ACL and define them in the interface, apply the ACL in the interface. Let's say the workflow, and later we will explain the detail, what's the parameters of the ACL. If we apply the ACL in the inbound direction, that means if the message, for example, now we use the traffic control, not about the route, only about the traffic. When we receive this message, because we define the inbound, right? When we receive this message, we will check whether to configure the inbound ACL packet filtering or not. If yes, we will take the message to match the first ACE. The first ACE means the smallest sequence number. And then if we match the ACE, then we will take the action. If the action is denied, that means this message will directly to be discarded. I will not take the message to the next step. Maybe we will send to the CPU, right? So I will directly stop the message to enter the devices. If the action is permit, that means this message can be received, and then I will send to the next step. So this is the action deny and permit. If the first ACE cannot be matched, we will take to match the second ACE. That means the sequence number of the second, maybe it's 20, right? And also, if matched, we will take the action, permit or deny. If not, finally, we will match one by one. And at last, if every entry we configured on the device cannot match, we will check the default ACE. And about the default ACE, the action is denied. So finally, the message will be discarded, cannot enter the forwarding process. Of course, you also can use a command to change the default action to become permit. That means all the message cannot match the entry you config, finally we will allow this message to enter the forwarding process. So this is the main process if you add the ACL on the inbound interface. But if you don't add the ACL technology on your interface, that means I will directly to receive this message and then to let the packets enter the forwarding process. So this is the inbound direction. And about the outbound direction, if we want to send some message out, then we also have to check whether we have to configure the ACL packets or not. If yes, we will take the match. And match the entry, then the action is denied. I will directly discard the message. If the permit, that means I will allow the message pass, then the message will be encapsulated successfully and sent out. If the first entry cannot match, we will continue to match the second one, and then to continue to match the rest entries if we cannot use this entry. And of course, if all the message cannot be matched, finally we also will check the default ACE and we will have the action of deny or maybe permit. If we don't add the ACL command on the outbound interface, finally this message will directly send out without any check. So pay attention, this is the workflow. So in this process, you will find the first one, you have to configure entry, right? The ACE. And about the ACE, the sequence number is very important because we will match the ACE one by one according to the sequence number. Smallest will be checked at first. The second one is when you create the ACE, the action also is very important because finally the action will directly decide the message can be passed or cannot. The third one is the default action also is very important because maybe some traffic cannot be match all the ACE. Finally, we will take the default action. And the last one is if you define lots of entries on the ACL, but you don't apply, that means this interface don't have any limitation. So pay attention. If you finish the configuration of ACL, you have to do the application. You have to apply the ACL in some special interface and special direction. So pay attention about this part. And how to match the traffic. Why we think this message belongs to this message is the special message we want to do the control. We will use a wildcard to match the message. And the wildcard is the inverse mask, and the format is very similar like the submask. And we can use this wildcard to in conjunction with IP address to describe a range of addresses. So we will use a wildcard to get the message we want to do the control. And the inverse mask is very similar of the subnet mask, but the meaning is different. 0 means the corresponding bit need to be compared, must be saved. 1 means the corresponding bit does not need to be compared. We can be different value. So like this example, if we provide one IP address 192.168.0.1, but we use different wildcard mask, the rest range will be different. If we use the wildcard value 0.0.0.255, that means the first 24 bits must be compared, must be same. So the representation of network address is 192.168.0.0/24. Totally 256 address need to be compared. But if we use the wildcard 0.0.3.255, that means only the first 22 bits can need to be compared. So this is a different meaning. And the special one is if we use 32 bits 0, that means we have to compare every bit of the IP address. This only can be represent one IP address, 192.168.0.1. If we use the wildcard 255, 255, 255, compare none of them, you can think this is a default route. Or maybe this is permit, or maybe action any. All of the message can be matched. So this is a different meaning. And someone maybe say why we directed to use the subnet mask. Because in the subnet mask, all the one must continuously. You cannot use the submask like 1110111, right? You have to use 111 and start with 000. All the value must be continuously. But about the wildcard, it don't matter. And here the example that shows you can use the wildcard value like 0.0.2.255. And if you use this wildcard, you can use one wildcard to indicate multiple segments. So this one is very important because in the ACL, we will use the IP address and the wildcard together to match what the traffic we want to control, because you have to select, right? So this is the function of the wildcard for the ACL. And later we will explain how to use the command to finish the configuration and to select the special metric and how to apply ACL in our interface, and then our interface can do some control. And about this video, we only talk about some basic concepts of the ACL. That's all.